Hi, everyone. Welcome back to another Build Hour. We're super excited to have you here today. We are going to be covering all things assistants and agents in the next hour. My name is Sarah Urbonis. I lead startup marketing here at OpenAI, and I'm joined by one of my favorite essays who came from New York. Alon, do you want to introduce yourself?
Yeah, so my name is Alon. I'm an engineer on the go-to-market team, also a solutions architect, and most recently on the developer experience team. And I'm really excited to be going through a lot of just assistants and agents conversation today and building one out to see how they work in practice.
So as a reminder, we created these build hours really with one goal in mind, and that's to empower you with the best practices, tools, and AI expertise to scale your company using OpenAI APIs and models. Now, we got a lot of great feedback from you all in our past few build hours that you want to see more building and demoing. So Alon's actually going to spend most of the next hour getting deep into code and actually showing examples how you can build assistants and agents that you can deploy at your startup or your company today. So to give you an idea of how we will spend the next hour, we're first going to go through some core concepts. We hear these terms, assistants, agents, orchestration. So we're really going to demystify all of these and help you understand when you can use each one. From there, we're going to get deep into the demos. We're going to actually build an agent, a customer service agent, where we're going to show you how you can really deploy it today. From there, we will go into our second demo where it's going to get a little bit more complex. So from there, we're going to actually build a multi-assistant system and show how you can bring it all together, and then show you how a real customer, Klarna, used exactly what we're going to cover today to save a ton of money and time and really create a better experience for their customers. As always, please use the Q&A function in the chat. So you'll see a little Q&A at the bottom of your screen. We are going to try to cover as many questions as we can during the programming that you submitted through the reg form. But as you have questions, please ping them in the chat. We have our team here who's going to be answering them through the chat and then also pinging some to Alon to answer at the end.
Yeah.
So with that, I'll pass it off to you and you can get started on concepts.
Cool. Thanks, Sarah. Okay. Sweet. So I think the idea is to first really cover the concepts, just get an idea of like what each of the definitions are and like the high level ideas, and then jump into the actual implementations. So let's get started. There's all these terms, assistants, agents, orchestration, that get tossed around. But the important thing to realize is these are just describing abstractions to describe an LLM system. The concepts here are more important than the actual terminology, especially since it's loose. So let's go over a little bit of the abstractions that we've used in the past for LLMs. In the beginning, we had text completions. So we just had some input text and we would get the rest of the sentence completed. And it turned out to be a quite powerful paradigm. However, it was kind of cumbersome to use. Now, what we really wanted was to ask for a specific result and get it back, instruction following. This was the next level of abstraction. After that, we entered a slight change with the chat assistant, where the assistant actually had this persona. And finally, we are entering the stage of instructions and functions, where we've just found it really, really useful to associate not just like this is a set of instructions we want to give the assistant, but also this is what it can do in the real world. And so to answer what is an assistant, it's just this notion of instructions and functions that we found really, really useful. Some people decided to kind of use the terminology assistant. Now, like I said, a lot of this terminology is very loose, and so it's more important to focus on the concept. Some people might call it assistant, some people might call it agent. That being said, let's give a shot at defining some of these terms. So directionally speaking, an assistant is just an LLM system that has instructions and tools. Now, commonly when people talk about agents, you start to think a little bit more about multi-step execution, self-correction, maybe a little bit of planning. There's some concepts I'm missing, but this is generally like how people use these terms. And then finally, orchestration really starts to talk about how you start to take these units and have them work with each other. And so the goal here is to accomplish much more, I guess, difficult long-term tasks. I want to be clear, these are very just high-level directional definitions, and if you've seen them differently in other places, that's fine. It's just to have a little bit of a common ground. Now, where does the Assistants API come in? So the goal of the Assistants API is to simplify these assistant-like experiences and, most importantly, give you access to really useful tools like code interpreter and retrieval. Looking at this like stack of capabilities, it obviously does single step. It has tool use. It can also perform multi-step operations, calling multiple tools or using multiple steps to reason, and it has some level of self-correction. When you run code interpreter, you've probably seen this in the past, where if it runs the code and it doesn't work, it'll try changing things and run again. Now, would we consider this an agent? Maybe, maybe not, but like I said, the actual lines are not as important as the concepts underlying them. So between the Assistants API and chat completions, maybe you're asking yourself, which one should I use? And this is a little bit of a breakdown of the differences between them. The Assistants API is primarily asynchronous and stateful, whereas chat completions is synchronous and stateless. You send a request, you get something back immediately, and there's nothing stored in the server. Now, the Assistants API can take multiple steps, where the chat completions is single turns. Assistants API, they both have function calling, but we also have hosted tools that we have built, such as code interpreter and knowledge retrieval in the Assistants API that you can make use of. And then threads are hosted within the Assistants API, and context is managed. And so the chat completions, you have direct control over your context and are required to do all of the operations around it, whereas in the Assistants API, we try to provide some of this. Now, in order to manage some of this complexity, there are multiple endpoints in the Assistants API, which might make it a little bit more complex to use, as well as the asynchronous stateful nature of it, where chat completions is a single endpoint, it's stateless, it's quite straightforward to use. So taking a little bit of a zoom out, the Assistants API can be thought of as like batteries included chat experience. If you're going for something of like perhaps medium complexity, where you want to have this like built-in access to like knowledge retrieval and code interpreter, don't want to have to host your own threads, this is like a really nice way to like get started quick. Now, chat completions might be better for like really, really small projects that don't even need these additional tools, or once you start to get into like more bespoke optimized systems, you really want to have more low-level control over what you're building. And so the chat completions API might be better there. Now, there's a question of, should I use agents? And the answer is really another few questions, is what do your workflows actually look like? The question of, should I use agents is quite vague on its own, given that agents can be so many different things. So the more important questions are, what do your workflows look like? And then what do your capabilities require? And so to answer these questions, we can take a look at some of the best practices for production systems that might have some of this agentic behavior. So the first one that I want to drive home is keep it simple. Especially as we talk about agents and assistants, it's really exciting to kind of just, I want to make the system built with agents and like orchestration. For most use cases, you probably don't need that. A single prompt and tools can go a really long way, and we're going to look at how. The next one is express hard logic as code. Code is a really, it is the best way we have to express computation. And so if you have conditionals, workflows, piping of data, you might be tempted to try to express a lot of this within the LLM itself or in more high-level abstractions that you provide to some orchestration system. Really, if statements go a really long way. Now, for the LLMs, you want to make tasks constrained. In production, you want to almost remove some of that freedom. LLMs are very powerful, but perhaps a little inconsistent. If you want to keep some of that consistency, you got to constrain what they're able to do. Spell out the tasks that you want, and talk about the edge cases very specifically. Now, this one is pretty important, and I don't think enough people talk about this, but you got to focus on the frequent user journeys. I think some people try to tackle too much all at once. When you focus on the frequent user journeys, you can really optimize the cases. Perhaps if you're making like an email client and you're talking about what kinds of search you want to, like if you want to have like AI search, you can actually enumerate like most of the cases that people will be looking up in a daily basis. And so really using your resources and effort to like make those perfect as opposed to making a general solution that scales to everything will be better in production. And the last one is build for your app's acceptable failure rate. So different use cases have different tolerances Some might be more forgiving. When they are more forgiving, you can try using more complex behaviors, like multi-step planning that might go wrong, or they might yield really incredible results. But if you want to have a production system that is a little bit more robust, where it's less susceptible to failure, then you really want to constrain and like use more conservative cases where you have a higher level of control over what the LMs are doing. Oh, and write evals. This is a huge one. Seriously, write evals. I cannot stress this enough. So with that out of the way, let's get to actually building an agent. So your prompt today is, your company is drowning in customer support tickets. Let's see if we can build an agent to automate it. Now I'm going to hop to my code editor and kind of talk a little bit about the setup that I have, but the idea is from now on, it's going to be very hands-on. I want to talk about the architecture that we'll be implementing. So I mentioned how prompts on themselves are potentially powerful enough to power an entire experience. We're going to talk about one strategy called routines that has been really useful in practice. We're going to implement tool calling, a little bit of self-correction, and then what escalation would look like in a real scenario when you want to pass it off to an like a real human assistant. And what I have here is like a little bit of the orchestration around, sorry, that's a misnomer, orchestration around tool calling. So the way that we pass messages back and forth between function calls and the actual systems that they call. Cool. So let's get started. Here I have my setup with cursor. I'm using just a color utility that I have to print colored text, importing OpenAI, defining my system prompt and my model, and have a very simple while loop. What it does is get user input, gets the messages, appends them to the history, runs chat completions with the given system prompt that I have, extracts the message, prints it out, and appends it to the history. Let's actually take a look at what this looks like. Cool. So say hello. I am demoing a lot of people. Say hi. Cool. So this is GPT-4o Mini. This is just the setup I wanted to show you, very basic setup. Now let's get into routines. I talked about this notion of how useful and powerful just prompts can be. Routines are this idea of taking a set of steps, an interaction that you might want to have with a human, and turning it into this like very well-defined checklist of steps that you provide in the prompt. We've seen this used in customer support situations, and it really mimics this idea of, instead of like a few well-defined structured steps where it might be something you can fill in a form, it still has this conversational feeling, but it can flow in a very like predetermined way. This is not exactly hard logic. This is softer logic and flow, and we can see a little bit later how we can integrate some more hard constraints into this setting. So taking a look at this prompt, your customer support agent for Acme Inc. Always answer in a sentence or less, and then this is the actual routine. First, we want to ask probing questions to get deeper into the problem, unless the user has already provided a reason. Then just make up a fix. This is for the demo. Once they are like, if they're not satisfied, provide a refund, and then search the ID and execute it. Now, I don't have any tools yet, so this is going to be pretend, but I want to show you what walking through this looks like. So let's say, hello, my Roadrunner catcher broke in half. I was trying to catch the Roadrunner, and it just split. Cool. So it gives me this this fake solution. I'll say, yep, I tried. Or I can say maybe, no. Let me try that. Go do it, try it, doesn't work. Yes, please give me a refund. Cool. I'll make up an order ID. Cool. Now, this is a bit of a hallucination since it doesn't have access to tools, but that's okay because I put it in this difficult situation where I told it to do something that is sort of impossible in the setup. But what I want to really highlight is the power of this routine architecture, where by having a set of steps, it can like softly follow this almost checklist that you would give a human. Cool. So now let's start integrating tools. I'm going to try to speed through this a little bit because tool use has been covered in many, many places. I'm going to define an execute refund function and the item lookup function, and essentially go through the same flow again. Say, oh, I want a refund. My e-catcher broke in half. I was hunting for bats. Yep, I want a refund. Cool. So now it executes the call. Now, very specifically, I have not changed any of the rest of the code. I have not implemented function calling or handling. All I've done is taking a look at the code. This is my loop now. This is what we're going through. We'll have I define this run full turn, which what essentially does is call the model with a given system prompt and some tools, get the response. If there's a response, print it out in yellow. If I don't get any tool calls, just that's it. That's the full turn. If I have some tool calls, just print out the names. Now, this is obviously not that useful. You'll see as soon as I do something afterward, it crashes because I haven't handled the actual response of the tool. Now, for my own convenience, I've implemented this function called function to schema. And I want to just briefly talk about this because I'm going to be using throughout the rest of the demo. But the idea, and you can ignore the implementation, is if I define a Python function with some parameters, maybe some like type hints and the docstring, this function will take the Python function object and spit out the corresponding schema. Now, this is mostly just because I'm lazy. I don't want to be re-implementing this every time. But the nice thing is also it'll automatically create schemas that match to your Python functions, and so they're guaranteed to execute. I promise I have unit tests for this elsewhere. But going back to the functions themselves, now what I can do is store them in this tools array. And right at the beginning of the run full turn, I can turn them into schemas. And it behaves exactly the same. This is my only change. Now, this is still not good enough. All I'm doing is printing the function. What I really have to do is run the function, give the result back to the LLM. So let's take a look at what that could look like. So everything else is pretty much the same. I'm extracting the tool schemas at the beginning. And then I am also just mapping the function name to the actual function. And this is useful because when a function call occurs, it'll tell you the name of the function, and you need to be able to access the original Python function that you want to call. Everything else is the same, run chat completions, get the calls. But now I've implemented this execute tool call function. And what this does is also extracts the name and arguments, prints it out, and then just calls the Python function. Then when the result comes back, we create this object that is similar to like the user and content objects that we interact with chat completions with, and provide the tool call ID that we got and just give it the result. I've put this inside of a while loop so that once we have the results back, I give the model a chance to respond. And so if we look at what this actually looks like, you can say, hi, my Roadrunner net broke. It split in the edges. I have. Nothing works. So I'm about to say, yes, I want a refund, but I want to highlight what these functions actually do. So Right now, they're just mock functions. I'll print out like a pretend execute refund and pretend lookup item. But specifically, the execute function requires an item ID to be called, which I could provide. However, I've also provided the model this lookup item to perform this search query. And this actually returns the item ID. And this doc string that I'm providing here is supplied to the model so that it knows how to call it. And the cool thing is I can just say, yes, please. And it should automatically look up the item, get back the item ID that I've hard-coded, and then immediately execute the refund with that item ID. And so this is where we start to get a little bit of this agentic behavior where it can do multiple steps, multiple function calls, use the results, and then inform me of what has been happening. Now, this is the beginning of this setup. But as you can see, if I just keep adding functions in this scenario, it can actually be quite a powerful construct. What really starts to happen is your routines might just start to grow longer and longer. And there are some cases that you might not handle. And so in a production system, you will also want this ability to raise this to a human. And so let's say an assistant or an agent that you've implemented is getting to the limits of what it can do. We can define this escalation function, which looks just like the others. I've given it the instruction to only call this explicitly if explicitly asked to, and will provide a summary and escalation report. And so this will be the last part of this demo, but I can run escalation and say my turbojet force speed broke. I just want to talk to a human. And this has been an explicit escalation, but you can imagine adding instructions where after a certain number of failed attempts, or if the user is getting frustrated, you can just automatically escalate to a human. This is the very basic setup for like what a simple agent can be, but you can actually scale this up to like many functions. We've seen in practice like anywhere from like 10, 15 functions, like according to how different they are, can actually work really well. So yeah, I'm gonna hop back to the presentation. That was the main setup for implementing an agent. Now, once you have one agent, when do you start to transition to orchestration? As I mentioned before, really you wanna approach this as something that you do in steps. You wanna start as simple as you can, really with just a prompt and functions, then maybe introduce routines, et cetera, until you get to this point where you might want to have an entire set of instructions for one scenario, but maybe want to have not just dealing with refunds and fixing, but you can also deal with other kinds of issues that come in if people are like asking questions about using certain items, or if they want to like ask questions about their orders. Maybe you start to like overload how much you have within this one system. And jumping ahead a little bit, I know a lot of you have been asking about like how do you do routing and triage. We'll get to that in a way that is like quite scalable as well. So these orchestration techniques that I have here are just a few of the ones that are available, but I wanted to highlight them because they're quite common. So the first one is handoffs, where you have this triage layer that determines what kind of question or like which agent would be best suited to deal with the question that is coming in, hands this off, loads in that agent, and then just provides, lets them answer the question essentially. You can also do nested calls where it's like within one function call, you will then invoke another call to OpenAI or whatever LLM that you're using and get back a response to the original triage agent, and then that forwards back. This is more useful for different scenarios. This one is a little bit construed in this example. They're quite similar, but if you want to have like multiple function calls and use the results all in one go, sometimes this is better to lay out within the function itself rather than just hoping that the model will make all the function calls that it's supposed to make automatically. And then finally, you can get into like quite complex systems. What I chose to display here is the manager, like one of the manager orchestration techniques where like one manager is like assigning tasks to different agents and they're communicating back and forth with the manager. There's also versions of this where like they communicate directly with each other. I think the models are capable of doing this to some degree. What I will say is, while this is very powerful and can express very powerful ideas, when you want really robust production systems, you probably want to stick to something more simple and easier to monitor, like handoffs or nested calls. I'm not saying managers always the wrong approach, but I think this goes back to the principle I was talking about earlier, where you have to understand the robustness required for your own system. That will tell you like which one is right to use. So in this example, we're going to use handoffs because it's quite a natural approach where once you've determined the correct agent to handle the approach, you can just pass it off to them and let it handle the rest. So this is a little bit of a deeper view into handoffs. Let's say you want you want to return the t-shirt. The triage assistant will highlight the correct assistant, hand off the conversation. Then that assistant will determine with its own set of functions what it should do, and then get back to you. And the nice thing here is because of this abstraction that we've defined of like an assistant or an agent that is instructions and functions, you can partition like the function space into like logical categories. So here we have orders, tech support, sales, but really it'll depend on which use case you want to handle, how you want to split up this case. There might be a question of how many agents should I have? How much should I split this? And the answer there is you have to try out a few different things. You can try out a few splits with only 1 or 2 agents, and then potentially you can like load in many, many more if you need. And this approach can scale quite well. Now, there is a question of how do we perform this handoff? Because to actually hand off the conversation, you have to load in a new system prompt and load in new functions. Well, there's a few different ways you can do it, but the way that I'm going to approach this is to try to do it in the most general way so that we can build any kind of system afterward. So let's jump back into the code. So let's review the code that we have that we left off before. We import OpenAI, define our routines and our model in the system message. We've defined the functions that we want this specific routine to have. We've set them in the tools. We've implemented this run full turn, which will take a system message, tools, and a set of messages that the conversation so far, and then call the model if it does function calls, handle the function calls, and do so until there are no more function calls, and then returns the messages. Excuse me. And then at the very end, you have this loop where it calls a user, gets the messages, runs a full turn, adds the messages back to the conversation, and iterates. This is where we left off last time. Now, we could just start swapping in the system message that we pass in and swapping in the tools directly. Like I could literally go in here and like maybe have this be a different system message. However, we have been talking about this notion of unifying this notion of it like instructions and tools. So let's do that. Let's define a class called agent. And I've picked these fields. You can pick more or less, but name, just to know which one we're talking about, which model we're going to be using, the instructions, which are going to be the system prompt, and then the tools array. Now, the tools array is actually, like we saw before, a tools array of Python function objects. And so we're still going to have all of the function to schema logic that we had before. Nothing else has changed, except I've wrapped the instructions, which is the system prompt, and the model and tools into a single agent. This actually corresponds quite nicely to the Assistants API in the way we have implemented that. However, the reason I'm using chat completions is I wanted to show this from scratch, how you can do it yourself. And then I've also defined this response object to contain the messages. This seems quite useless right now, and it is, honestly, but I'm getting ahead of myself. I'm just doing a step that will make the next few steps easier. And if we go back through the code, before in Run Assistant, we would take system messages, system message, tools, and messages. Now we just take an agent and some messages. Everything else is the same. The only differences being now I grab the model from the agent that I pass in, I grab the instructions from the agent I pass in, and that is it. And if I were to run this, it would work identically. Now, the way that I define this agent is instead of spreading out the definition of the system prompt and the tool separately, I now put them all into one agent with a name, instructions, and tools. this just wraps up this nicely. It is not necessary for our current system because I only have one agent, but we are about to explore what happens when we want multiple agents. So if we have, the nice thing here is I'm gonna do this quickly. So I can run this demo. This is 6. So it should run just as before. I can say, oh, I want a refund. Okay, you can trust me, this works. Now, the cool thing is I can just define a different assistant. I can be like pirate assistant or pirate agent, have an agent with just instructions being talk like a pirate, and do name equals pirate agent. And then I will provide it, maybe I'll give it one tool just to show you guys what this interface looks like. So I'll define a tool here called walk the plank. And I'll give it a rule that says only call this function if the user claims they are the captain and tell you to walk the plank. Cool. So now what I can do is really simply, instead of using the agent I defined before, I can just define the pirate agent. And I'm going to go back in here, run the same demo, and I can say, hello. And I'll get the pirate, and I'll be like, walk the plank. This is live, so hopefully it works as expected. Okay, so commanding me, yeah. But what if I say I'm the captain? Then I am the captain. And I tell you to walk the plank. Did I not pass it? Oh, I see. I didn't pass the tool. Cool, I was gaslighting myself. Let's try that one more time. Walk the plank. Boy, I am the captain now. Cool. So this kind of works as expected. The nice thing is I can just define multiple assistants and like switch out what they do. I can switch it out really easily. All in the code right here. Now, we get back to the question of how do we perform this triage? Because what we could do is we could hard code a first step of just taking in a request, determining which of the possible agents is best to call, and then just loading in that agent here and letting the conversation flow. But the models themselves, this is a form of classification, and the way these models can perform classification is also through like function calls, right? Function calling is a form of classification among functions that you provide. And so one way we can implement this notion of handoffs is define like a transfer to function, right? So I'm not going to do anything special. I'm just going to do like transfer to captain. And earn success, right? So right now this function does nothing. But notably, if I give it to the agent, I can make a request like, I want to talk to the captain. And appropriately, it'll transfer me to the captain. Like I said, right now this function does nothing, so nothing happened. But this is sort of to demonstrate the agents are at least capable of understanding what these transfers entail. And so we can express this like handoff through the functions themselves. And the way that I found quite intuitive to express this handoff is instead of returning a string, we can return like an agent directly. And so let's say I'm going to define a captain. So captain agent agent and then talk like a pirate captain. Always, let's say, always remind the user you are the captain. And then I won't pass any tools just to show. So I've defined another agent. Nothing will happen yet. What I have to do is ensure that if this function returns this captain, so let's do here, I want to be able to express that, like, if I say this, I want the transfer to happen. And the changes required to do this are actually quite simple. So if I go back to our loop, then when we are handling the return call, this is the result of the function call. And I can do quite a simple check. If the type of the result is agent, then we can transfer it to the agent. And what that means here is, let's define a current agent. Use that current agent everywhere we're using this one right now. And then if this result is an agent, then then essentially I'm just deciding to define that that means the function has transferred to this other agent. And so I can update the function, update the current agent, and potentially make the result be transferred to that agent, right? And what I'm saying here is just like, this is the message that is going to be appended into the message history, just showing the model that there's been this transfer. But notably, the current agent will be updated, and so the system prompt and the tools will be updated with it. I think this should be it. And so if I give this a go, I can say, oh, maybe just let me change the name of the pirate agent, pirate agent. So instead of just printing assistant here, we want to print current agent not name. Cool, and this is just to show which agent we are currently talking to. And the same with the function calls. Maybe we'll do current name. You're seeing some live coding here. Cool. Then we go back to where execute calls is passed, and we do current agent dot name. Cool. So this should be all the changes that we need for this to work. Let's give it a shot. So I can say, hello. I want to talk to the captain. Now remember the instructions we gave the captain. They should always say that they are the captain. And so I can maybe just ask, are you the captain? I want to talk to captain. And so now there will be this function call. The pirate agent will call the transfer to captain. And because it returns the agent, now I'm talking to the captain, which I misspelled, but that's great. And I can ask, are you the captain? And just say yes. So we showed a very, very simple case of this handoff, but how simple it can be represented through just like the return value of the function. Now, this is not the only way to do this, but this is my preferred way to do this because it's quite straightforward. Cool. So now let's jump into, so actually this next tab is exactly the changes I just made, but with a few more agents implemented. To prove it to you, I can just go through here, show you no magic, nothing else has changed. I'm using the exact same code from last time. I've defined a few more agents. So now I have a triage agent that will determine the right agent to route to. And the functions I've provided, the tools I've provided, are a couple transfer functions. Now, the question is like, is there naming? Does it matter? No, like the naming of these functions doesn't matter. It's just a way to indicate to the model what they do. And you saw all of the changes that I did. There's no magic, nothing going on behind the scenes. So I have the transfer to sales agent, which just returns a sales agent, and transfer to issues and repairs, which will return issues and repairs. If we go down, you might recognize the issues and repairs agent as exactly the one that we had before, with the two functions that we had before. And we also, I implemented this sales agent, which has these instructions. It has its own routine, which we can just go through. So let's give this a quick demo. Let's say, hi. I, let's say, had some rocket skates that exploded on me while trying to catch the road runner. I don't know how many of you are understanding this reference, but I hope it's more than a few. Cool. So it understood that I want to talk to issues and repairs. Call the function, and now I'm talking to issues and repairs. And I can say, yes, I went quite fast and they just blew up. Nope. They seemed fine. Oh, all reset, but still not working. Yep, please. So we had the exact same flow as before, but now I was able to talk, like I was passed around between the agents. Now, I forgot to mention one function that I implemented here called transfer back to triage. And this is often a problem that people deal with in implementing these triage systems, is like, how do you know when to like go back and re-triage? And my answer is just make another function that lets you do that. And so if you, I've provided this transfer back to triage function, which again, just returns the triage agent to both the sales agent and the issues and repairs. So I can say, thanks, I want to talk to sales now. And I'll get transferred back to triage. The triage agent automatically realizes that and then transfer me to the sales agent. Now I'm talking to the sales agent. Yes, the road runner is going too fast. Acne Turbo Boost sneakers. Nope. Interesting. Yes. Yep. Oh, on a full moon. Okay. Yeah, makes sense. Let's do it. And so it'll have this order summary. Now, I added this confirm because a lot of people would ask, oh, if you're just giving them the function, doesn't that mean, like, what if I want some confirmation before running the function? And I guess my answer is, you don't want to confirm before, you want to confirm after, during, right? Like the model can do whatever it wants, but once it does it, it's your job to make sure that like, to do the checks in that. This is a form, I guess, of hard constraints and guardrails. I've built just directly into the execute order function to just get the user input and then get a confirmation. And so this is sort of to respond like, if you don't want it to call a function, you want to have secondary confirmation, I can just say like, look, it did it, and I can say no. And then it says order was canceled. Like, let's try again. And then I can say yes, and then order was successful. And as you can see, this has been one long conversation, just swapping between agents. And I can go like back, I can say like, now my magic mirror broke. It might try to sell me one. Yeah, it's trying to sell me one. No, I want to get it repaired. Cool, so transferring back to triage and then triage back to repairs. And the nice thing is you can build this sort of graph just with like as many agents as you want. And again, this is all just the handoff routine, but I want to show like there's going to be a lot of frameworks that try to make agent usage easier. This is really just to show you what's behind the scenes. You can do it yourself. You might want to buy one of these systems, but it's at least good to understand what they're doing behind the scenes. Cool. So that was pretty much the demo for the orchestration. Now let's look at a real world example. Now, Klarna we worked with Klarna to develop this AI that is doing the work of 700 full-time assistants. It's driving 40 million in profit, and is bringing the average inquiry time from 11 minutes to 2 minutes. And how was it built? This might look familiar because it's exactly the architecture that we just implemented from scratch. Now, at the time, it was much more complicated because we were developing this for the first time. And of course, this is using our old models, but the architecture is quite similar, where we first have tier 1 routing, where it determines whether it can, like, which assistant it can talk to. The tier 0 is the triage. Tier 1 would be like the appropriate assistant, which has access to retrieval and functions. The important thing here is a lot of these things work through functions. And so the reason I didn't talk about retrieval and some other forms of tools is because they are just all tools at the end of the day. And we have a little bit of the routing. Now, this system that you just learned to implement was actually quite impactful. The fact that we can scale to such a large number of people with like such a fundamental, like, it shows how fundamentally robust the system is. And it's being used in production. So I think this is kind of going back to the point I was talking about, where we had the more complicated orchestration techniques versus like simple handoffs. The reason you like simple is because it's easy to understand what's going on, it's easy to test, and it's quite constrained. There's no like long-term planning. It's just like one-off hops with like very well-defined instructions, very well-defined handoffs. And Klarna did a fantastic job of like proving this out and sort of shipping this to production and seeing how it's going to affect users. Cool. So I think we can start to wrap up and go into Q&A. Okay. Let's see on the code I shared. Yeah, I can share this code. Totally. Cool. So multi-turn versus single turn isn't chat completions with function calling multi-turn. So you can make it multi-turn. The question is, isn't chat completions already multi-turn with when you use function calling? Technically not, right? When you make a single call to chat completions, it'll indicate which function it wants to call, but it does nothing else, right? Like, you will send your message history, it'll give you back the the intent of calling that function, but that's it. It's one turn. This is sort of what I had at the very beginning, where it just specifies, like, tells you what it wants to call, but it's up to you to actually implement calling that function and then providing the response back. Cool. How would you implement guardrails to make sure the agent responds appropriately? I think there's two ways. There's like guardrails in terms of like nudging, which I'd say if you want appropriate responses, you can use few shot examples and like prompting techniques to make sure that the outputs are more in line with like the tone that you want. However, if you're like in a sensitive situation, what you can do is add like a final layer where no matter what the model responds, you take another pass and you like look at what it responded and potentially have like another set of checks where you specify, does it like satisfy this? Like, is it friendly? Is it like revealing any like sensitive information? And you can just have this like as one more additional call. Maybe like this is kind of like tangential to like the entire orchestration, because you can have an entire like system being orchestrated, but then like once you get back the response, you can then run this on top of that. So you can have a single agent, multiple agents, kind of doesn't make that much of a difference for orchestration, guardrails, and you can put them in wherever you want. What are evals in the context of building agents? That's a great question. I'd say broadly, any way for you to have confidence in the fact and like that your code is doing what you want could be considered an eval. Now, I think what this question is getting at is like when you have turn-by-turn conversations or like chat-based conversations, how you evaluate that, right? Because when you have a workflow or like math exams and you like give the model a problem, you know what the right solution is, it's quite straightforward to eval. Even if it's a little bit unclear, you might need to like use another model to evaluate the output. In turn-by-turn conversations, there's a few different techniques. You can evaluate the conversation as a whole based on like user conversations. You can construct scenarios where like you essentially pretend you've had a conversation up until a certain point and then just evaluate the next message from the model, which gives you a lot of controllability and robustness to see like, is that response what I would expect? Then there's more end-to-end solutions where you can use like another agent to play the role of a user and essentially give that agent like all the information it needs to ask questions like, look, your like Roadrunner like skates broke. They've been broken for this long. Like pretend like give as little information as possible, be like really like closed off and like make the assistant ask you all these questions, right? Just make it like the user persona that you want, and then just let it have a conversation. And then what you can do is like, if you know what the resolution is, which you do because you're building this eval, once the conversation is over, at the very end, you can pass the entire conversation into context of another model and ask, did this conversation satisfy whatever constraints that you wanted? Did it get to the right solution? You could even have the user agent have a function that says, I am satisfied or I am not, do the rating, etc. There's a few ways you can do it, but using another model is quite a like a nice scalable end-to-end way. Okay, I just talked about how you would evaluate multi-turn conversations. For clarity, I can hard code rules for the agent to follow. Can I combine a series of rules for the agent to follow while expecting 4.0 within the system to utilize its capability that are required by the rules? I think what this question is getting at is how can you mix defining the steps that you want specifically versus giving the model a little bit more freedom to choose how to do things. I think my answer there is it depends on your case, which one you want to do. Like laying out the steps very deliberately makes the system very robust and like resistant to failure. It also makes it a little bit less creative and potentially like less capable. I think if you like make the rules that you define, in mine is like a very step-by-step guide, but like one of the steps I specified, look up the ID and then return it, right? And it provided a function to look up the description and then get the ID. I think you can sort of scale that where the instructions that you give might get a little bit more abstract, more high level, and let the model interpret it however it wants. So is Klarna's assistant open source and available to adapt? No, I don't believe it is. We can't share like more than this like general architecture about how it was done. The code that I wrote was for demonstration purposes. This is not to say they're running this exact code, but this exact code, like this code is the flavor of handoffs, which I think is like the high level like concept that you want to scale with. How can we manage long user conversations with agents? This is an interesting question. I think if you have like a lot of models are just getting really good at managing long history already. I think my question would be like, when would you want to do this? If you, excuse me, LaCroix is getting in my system. If you want to scale these conversations to like hundreds, thousands of messages, maybe you start to get into like a bit of a context issue, and there's a few approaches you can take to potentially like summarize parts of the context or like use retrieval to like load in necessary parts and like discard them from context. We actually do a lot of this in the Assistants API. So if these are not things that you want to implement yourself, if you want to have the context managed for you, then the Assistants API could actually be a good tool for you to use. How would you recommend orchestrating a set of agents all working concurrently on the same task? That's a good question. I think the architecture that I showed can potentially deal with this. So the architecture that I showed was like primarily this handoffs, but if you notice, like there's nothing stopping you from calling the model from one of the model's functions. And so like if, for example, the like lookup description function here, let me like hop back. So if like this function, I just wanted to do like run full turn. I guess this is a bad one. But we could do like maybe like execute order requires like doing a little bit of research. Actually, this one's quite, you wouldn't want too much freedom in execute order. But let's say like lookup item, right? Maybe there's like a few different ways to look it up. And like depending on some of the return values, you might want to take different decisions. You could actually do like like multiple steps of calling functions here. And if you want to make them asynchronous, like you can just set them to like run at the same time. This is just one way you can do it. But I like to think of things like, honestly, the system of orchestrating assistants and agents is not that different from the like orchestrating like threads when you're like implementing multi-threaded systems. So if you're curious about that, I recommend you look into like multi-threaded systems in general, and a lot of the things map over. Cool. We're gonna do one more question. How can you get your agent to connect with external resources via API calls? So in short, you have to implement the API call yourself. Like if I were to do this in code, I would do like import requests, right? And then if I want to implement like a get weather function, I would do like I don't know. This was autofilled, but something like this, right? And so I don't know if this works, but you would have to essentially do the API calling on your end, provide this function to the model, which remember, this function is getting mapped to this sort of schema. And then when you get back, you just supply the response to the agent. Cool. I'm gonna just quickly answer the last one. It's like whether you should do this in Python or not. Do whatever you want. Like you can do it in Python, you can do it in whatever language is most comfortable for you. Cool. And then here's a couple of resources. We have the Assistants API overview, which is a set of docs to like walk you through the process. There's also this is a cookbook. We also have some guides, and then we also have the Assistants API Quick Start, which is a repo that you can use to like. It's a very basic application that uses code interpreter, retrieval, streaming, all in like Next.js. So it can give you like a starting off point to start playing with the Assistants API yourself. Cool. Cool. And yeah, we're gonna send a follow-up email afterward. We're gonna have a recording of this conversation, send you resources, and you should come back on the next build hours to talk about multimodal RAG. Cool. Let me back.
Cool. Thanks, everyone. Great questions. We will send everything out via email and hope to see you in the next one. Bye.